that look familiar at all?
Base, height?
Yeah, yeah.
It's a square?
Yeah, a rectangle, huh? That's the area of any rectangle, base times height, right? Anyway, whatever, that's not part of the thing. So all we have to do is plug in. They want us to, they're telling us A is 55. They're giving us this formula, A equals B. So you don't have to memorize the formulas. Not required to memorize the formulas. A is BH. They're just giving me A, and they're giving me B, and I've got to plug them in. So A is 55 right there. B is 11 right there. We get 55 is 11 times H. Does that make sense so far? We good on that? Now what do we do there?
The area.
Where they're wanting us to find the H.
Yeah, that's 605.
So yeah, good. H is saying I want to be alone. Yeah, and it's got, now why don't I, so if H is saying I want to be alone, which is what the letter's always saying, huh? How do we get the H alone? We got to get rid of that 11, huh? Should I subtract the 11? It's not subtraction, is it? How do you know?
Multiply.
Yeah, that's times, so the opposite is divide. Does that make sense? We always do the opposite. So if that 11 was added to the H, I would subtract it away, wouldn't I? But it's right next to the H, right against it means times. The opposite of times is divide. And whatever you do to one side, do to the other, like that. Does that make sense? And what's happening on that other side? 55 divided by 11? Going to be 5. So H is 5. And we're done with with number 1. Is that making sense? How are we doing? So let me go over one more time. So they're going to give you the formula. You don't have to memorize it or even write it on your 3x5 card. They'll give you A is BH, and they told me the A is 55 and the B is 11. So right by the A I put 55, right by the H, or I'm sorry, the B I put 11. So I'm just plugging into A, plugging into B, and the H is still sitting there as H. Does that make sense on the first step? I just plugged in what they told me, and then I could tell they wanted me to get H. So I thought, well, how do you get H alone? You got to get rid of whoever's next to him, huh? And it's multiple. The 11 is right next to him, so that means times. So the opposite would be divide by 11 on both sides.
That's fine.
So H is 5. Good? All is well? All right. Okay, so there's number 2. So they're giving me another formula. Anybody know what this is the formula for? Well, that's some hard one. I don't know. Whatever it is. Just plug those things in and see if you can solve for what is missing there. So plug in what they're giving you and solve for what is missing. Okay, so basically we're going to plug everything in. So the 33 will go, whoops, where will it go? It'll go right there, yeah. And the B is there, and the little b is there. So we'll get 33 equals 1/2 H 6 plus 5. Good so far? I just plugged everything in.
Oh, yeah.
And now, where do we go from here? Well,
We put 6 plus
33 is 1/2 H. Yeah, and what is 6 plus 5?
11.
11. Good to there so far?
And then 33 between 11.
Okay, so everybody good to hear? So far so good? Now remember the name of the game. What is the name of the game? H is saying, what is the letter always saying? I want to be
She
alone.
want to be alone.
Yeah, so let me put the wall in here.
To be alone.
Yeah.
All right. So she wanted to say, we've got a gender on the left now.
Yeah, baby.
Yeah, all right. So this is not a gender neutral problem.
Okay.
All right. Sorry, we're just having fun. Not most expense here. All right. So all right. So H is yelling out, he or she or whatever H is wants to be alone. So that means we're going to have to get rid of the half. Going to have to get rid of 11. Really, you could do it either order, doesn't matter. Why don't we do the 11 first? Yeah, how would we get rid of the 11?
Because it's divided, 33 divided by 11.
Yeah.
Perfect.
Right. It's nice, huh? Yeah, because that 11 is times. We always do the opposite, right? So the 11 is times, get rid of it by dividing. The opposite of times. So yeah, right on the money. So we come in here and we divide by 11. Whatever we do to one side, no choice. Same thing to the other. These cancel. And so that gives us 33 divided by 11 is 3. Half H. Good to there so far?
Yes.
Now, H is still saying, I want to be alone. It's almost alone. We just have that half. So what are we going to do? Get rid of that question, comment?
Why aren't we getting rid of that fraction?
Hey, we
I did say that earlier, didn't I?
Multiply times.
Yeah, I mean, you could. It's really either. I just said that for convenience earlier. You don't have to. You could have. Yeah. So how do we get rid of that fraction?
That's dividing right there.
Yes. See what Manuel's saying? A fraction is really dividing, isn't it? So what's the opposite of dividing?
You said that multiply into this.
Multiply by the 2. You see, remember the hitman. What takes out denominators is you multiply by that common denominator, right? So I'm going to multiply both sides by 2. That's the opposite of a half, because a half is dividing by 2, right? If I said half the people got A's, that splits the room in 2. That's dividing by 2, right? So half is dividing, so the opposite of that is multiply. So you multiply this side by 2, and you multiply that side by 2. And he's a hitman. Remember what he does? He's over 1. He cross cancels that 2, right? Because any whole number is really over 1. See how that's the opposite of a half? It's upside down of a half, and it cross cancels on that. Yeah, Carlos.
So after you add the 6 and the 5 to get the 11, did you just divide or just subtract?
I just divided, yeah, because that was times, so I had to divide. If it was added, I would subtract, right? But yeah, that 11 is right next to the H multiplied, so I had to divide, yeah. All right, so now we're to here. We get rid of the half. So whenever you have a fraction, you get rid of it with the hitman, meaning multiply both sides by the common denominator. So what do you get? 2 times 3? 6. These are gone. It's just H. H is 6. We could have done that earlier. Christina, right? Christina was pointing that out. She's totally right. We could have multiplied by 2 on both sides up here and got rid of the half right away and made that 66. Would you prefer that? Let me go back. Either way is fine. We'll give you the same answer. That's the nice thing about it. As long as you do the right steps, the order doesn't matter. It'll work. So right here, let me go back. Let me show it one more time. I think it'll be helpful. One more time. Come on. 33 equal to a half H times 11. You could have said, look, there's a half. I'm going to get rid of that right away. That's probably a good idea. How do you get rid of a fraction? You multiply by 2, by 2. It doesn't matter really where if you do the 2 here or there, whatever. It's just multiplying the right side. That would hitman take it out kind of thing, huh? So you have 2 times 30. You'd have 66 is 11, or H times 11. You see? And then what would your last step be? Divide, huh? You still got to get rid of that 11, which you got to divide because it's multiplied. See, we get the same answer in the end? It doesn't matter. Basically, you have to get rid of the half by multiplying by 2, and you have to get rid of the 11 by dividing. Either order. Is that getting more comfortable with how we get things alone? We always do the opposite of whatever's next to it. So if there's 11 next to it multiplied, we divide. If there's a half next to it, we multiply by 2. That's how we handle fractions, is we multiply by whatever's in the denominator. And that 2 is really over 1. That's why it cross cancels, huh? Whole numbers are over 1. That's why they're the hitman. They take out the denominator. Is that good?
I forgot that he's not.
Don't forget the hitman. All right, we good? So here at number 3, I'll bring it over here. They're giving me F equals 2GH. And they want me to solve for H. So this time, it's the same kind of stuff, but it's lots of variables, or, a couple letters there. So they're wanting me to solve for H. I'm taking this equation.
Okay.
And their H is saying I want to be alone. Getting the idea?
Yeah. Right there we can just get F equal, and we leave the H alone, and we send 2G dividing.
Good job.
F.
Exactly. Does that make sense? Because H is the one saying, right, because they're asking me for H. They can pick any letter to get alone. So H is the one we're trying to kind of stay focused on the one. Circle it if that helps you. Like that. Just circle it. Focus in on it. That's the one we're trying to get alone. It's like sports. Got to keep your eye on the ball. Stay focused on that H there. So we've got to get that H alone. So what do we do to get that H alone? Divide, by 2G. Whatever you do to one side, no choice. Same thing to the other. They're both gone. H is F over 2G. On that, Carlos?
So are you dividing because the 2 and the GH are together as multiplication?
Correct. Exactly. Exactly right. The 2 and the G are together multiplied by the H, so the opposite of that is divide. Exactly. And we get H alone. That was the goal, to get H alone. Is that making sense? Same kind of thing, it's just lots of letters. So whenever there's something multiplied by what we're trying to get alone, we divide it. Is what we did there. All right, let's. Okay, so 7x plus y equals 9. I think it'll really help you. I don't know if you've been doing it, but if you put the wall in there with the equal sign, I think it might help you look at it correctly. So the equal sign is the separator. There's the two sides. So see if you can do what they're asking for there. Right. Y is saying I want to be alone here. So what do we do to get y alone?
You put y and send the 7x minus.
Yeah, so here's y. Y wants to be alone. What am I going to do? If y wants to be alone, the 7x needs to leave. How do I get the 7x? How do I get rid of that 7x? Do I divide?
It's adding right there.
It's adding, so what am I going to do? Subtract. Subtract. Is that good? So we always do the opposite operation. So if there's something added to what you're trying to get alone, then you subtract it. So I subtract 7x, and whatever you do to one side, no choice. Got to do the same thing to the other to keep the balance, right? Subtract 7x, and this is 9 minus 7x. Can I subtract 9 minus 7 there? No, they're unlike terms. They have to just stay separate like that. No, you can't make it 2x, huh? If that was 9x and 7x, then I could make it 2x, huh? But the 9 doesn't have an x, so they're not like terms. It just has to stay just like that.
And we stop right there.
And we stop right there on that one. Is that good? Make good sense? Okay. Number 5. Okay, so D equals 1/4 FK. There's the wall of separation between the two sides. Multiply both sides by 4. Is that good?
Yes.
And then just takes it out, huh? So then this is just FK. The other side is 4D. So see how the 4's cancel on the one side, but the other side it just stays, huh?
Yeah.
Good to there? Now, what are we trying to get alone here?
Okay.
K, yeah, they told us to get the K alone. So what am I going to do to get K alone? Good, exactly. Divide by that F, huh? Both sides, there it is. 4D over F. Is that getting more comfortable with those fractions and how that works? Kind of the same thing every time? 4D over F there. Any questions on that one? All right, I'll move on if you're good. Yeah, let me write out that. Don't worry about that. What's that funny little symbol right there? What's that?
P.
Pi. Yeah, it's like P in the Greek alphabet. Totally. It's just treat it like any other letter. It's actually a P in the Greek alphabet. You guys know pi, right? What is pi? 3.14? Yeah. Anyway, we're not going to put in 3.14. You don't have to do anything with that. Just treat it like another letter. Don't do anything fancy with it. Just treat it like any other letter. Pretend it's a P. So it's just a Greek P is all it is. So I'd encourage you to put the wall in there. It'll help you to look at it right. And then you got to keep your eye on the ball. Who's the ball here? Who do we want to get alone?
H.
Yeah, see how they're asking for H? You can circle it if it helps or whatever. So there it is. Keep your eye on the ball. Focus on that H. You want to get that H alone.
We get P plus 5P.
So in an effort to get H alone, remember our goal. In the very end, we want H all by itself, huh? I want to get H, I want to get rid of all this stuff. So take a look at the structure up there. The 6 pi and z are all multiplied right next to the H, huh? So at the end, I will divide them off.
Yeah.
But first, I'm going to get rid of all this stuff. So that makes sense. How do I get rid of this whole big added chunk? Minus it, huh? Yeah. So remember, you get in the hang of how this works. We always save, we're trying to get the thing on, so we get rid of the stuff on the outside first and then get down to the, like peeling an onion. You work from the outer layers on down to the middle. So start with this outer stuff. Get rid of this outer stuff first. And it's added stuff, so yeah, we subtract 5 pi z squared, and whatever we do to one side, same thing on the other side, minus 5 pi z squared. And that's gone. And then that brings us down to, what do we have now? V minus 5 pi z squared is 6 pi z h. Is that okay to there? Does that make sense?
Yeah.
What do we do now? H, here's the ball still. It's saying I want to be alone. How am I going to get rid of that 6 pi z?
Dividing the other side of the equation.
Yeah, divide. Are we okay with that? Is that making sense? Just divide that whole 6 pi z. And whatever we do to one side, same thing on the other. One big bar, 6 pi z. These cancel. H is alone. There's our answer on that. Yeah?
So what happened to the minus 5 to the minus 6? Would it be 1?
Say it one more time. What was your question?
No, I
Carla?
got Karina.
Karina.
I got confused with the minus 5, which
So the minus 5 pi z squared totally goes out and just showed up here, right here. So that making sense. So we started up here, and I wanted to get rid of this whole big chunk, the whole 5 pi z squared, the whole thing. So I subtracted the whole thing, whatever I do to one side, did to the other. So it's gone here. On the other side, I just wrote them sideways instead of vertical.
Oh, I get it.
Yeah, all that is sideways instead of vertical.
Oh, okay.
On that. Good. Other questions?
Let's stop there.
Yep, that's it. H is alone, so we stop there. Is that making good sense? Okay. So question number 7, they want us to find the area of that shape.
Find the area?
Yeah.
A little shape?
So, in other words, they want us to find all, whoops, I'm not doing that so good. They want us to find all of this area. Does that make sense? All the glass area, basically. How much area, surface area, there is. How are we going to do that? That's kind of a tricky question. This is a pretty hard one. How do we find the area of that weird shape? Do you all know how to find the area? Say you have a rectangle. What if you have a rectangle that's 3 feet wide and 2 feet tall? Just one side times the other, huh? You comfortable with that? Because you can picture it because it's like 3 squares wide and 2 squares tall, huh? See, there it is. There's an example. 2 squares tall, 3 squares wide. You know there's 6 squares there. Like if you want to buy new carpeting for this room. So you buy carpeting in square feet or square yards, and they mean literally squares, right? Foot by foot squares. This is a square foot. It's about that big. Yeah, that's about a square foot, isn't it? Something like that, right? So it's how many of those to fill up the room. So like if you have a 2 by 3 thing, there's going to be actually 6 squares. Each of these is 1 by 1. Right? If this is 2 tall, this is 1, 1, 1, 1, 1, right? All right, so that's the kind of thing we're going to do with this shape up here. How are we going to do it? What I would suggest is bring this line down right there. And this is 12 from there to there. And how far is it across here? From there to there. Yeah, oh yeah, it's 19. It's the same as the top, yeah. 19. So this is 19. So then how far is this right here? And how far is this right here?
We get 37 minus 19.
Yeah, 37 minus 19.
That gives you 18 divided by 2. That is 9.
18, and then divide by 2. These are each 9. Good job.
And then we multiply.
Hold on. Let's make sure everybody's good there. Manuel's off and running, but you're right. Good job.
But then
Do you see how we got the 9s there? So see what we were doing. To find out, we know this is 19 in the middle. So Manuel was saying just take 37 minus 19, and you'll get 18, which is the 2 extra edges, so they must each be 9. Is that making sense? How are we doing? Is that good? Let me talk about that again. So again, all the way across, the bottom is 37. And we already know the middle section's 19. So if you take all the way 37, subtract 19, you get these 2 extra pieces, don't you? And when I subtracted that, I got 18. So these are each 9. I divided that by 2. It's got to be 9 and 9. See how the whole bottom makes 37 now? 9 plus 19 plus 9 goes back to the 37. Is that helpful? Is that good? So again, the whole 37, take away the 19, take away the middle, gives you 18 for the 2 outer pieces. Therefore, they're both 9. 9 and 9 to make 18. Okay, now, do you see what we have? This is a big rectangle right here in the middle. If we can find the area of it, can we find the area of that middle rectangle piece? What's the area in the middle? Yeah, it's whatever. Remember, for area of a rectangle, area in the middle is going to be 19 times 12. Because it's just one side times the other. Which is, what is that one? 190 and 38? 228? 228. Good so far? Am I going too fast? So this thing in the middle is 19 by 12. So remember when you have a rectangle, I'm just going to do it in pieces here. I'm just going to take the rectangle in the middle. It's just one side of the rectangle times the other side. Like if you want a new carpeting for this room, how much carpeting to fill up the whole room? It's a big rectangle here. You would just need to take a tape measure and measure one wall and then another wall. Just one wall times the other, and that's how many square feet of carpeting you'd have to buy to carpet the room. So that's what we're doing for this middle rectangle. It's one side times the other, 12 times 19, 228. So that's the middle. Now how about these 2 triangles on the sides? Let me give you a tricky idea. What if you took these two triangles, what if you broke this off and put it right here? What would it make?
Another square.
Yeah, the two together would make another rectangle, huh? Did y'all see that? These two triangles put together is just one more rectangle. So, and we want to know the area for them together. So if you took these two, snap them together, it's going to be 12 times 9, right? If I took one of them and put it on the other side,
108.
it would go like that, right? And so it'd be one side times the other. So the sides, area of the sides is 9 times 12, which is, 108. 108. And then how do we get the total area?
Divided by 12.
We're going to add those two, right? I'm going to take this and add them to get 336, I think.
Why wouldn't you divide the 108 by 2?
108 by 2.
You said 336?
Because that would be wrong.
No, it's not.
Let me explain a little bit more. So remember what I'm doing for these two little triangle pieces. I'm fitting them together to
Put it on
make a
top.
rectangle that's 9 by 12. So that's both of them together, huh? That's all the rest of the area. Is that making sense?
Yeah.
So imagine cutting it out with scissors like construction paper. You would have this middle section and these two triangles, and if you put these together, it's really another rectangle, isn't it? So I'm just saying find the area of the middle, 12 times 19, and find the area of the one other rectangle, which is the two triangles together, 9 by 12. 9 by 12. On that. Is that good? So I never used the 15, did I?
No.
Didn't need to.
You can also you can add 19 plus 9 times 12, and that give you the whole.
I'm sorry, what's that?
You can go and do 19, the center,
Uh-huh.
by the added the 9. That's the square, the area. So that gives us 28. We
Oh,
multiply it by 12,
nice. That's another
and
good
that
way.
give you the area.
You're totally
Because
right.
we have a full square now.
So you're really good at this. Let me bring everybody else along with this. Is this comfortable what I'm doing? No more fancy methods. You're right though. You're totally right. That was tricky. Everybody good with the normal method? Is that making sense? So we get the middle, and then the two triangles make another rectangle, 9 by 12. Never even use the 15. They didn't need it.
No.
Sometimes they give you extra information. So that would be our answer, 336. And what are the units on that?
Inches.
Squares.
Square inches. Do you know what square inches are? Like IN with a little 2. You know, like x squared.
IN.
This is inches squared because it's literally an inch by inch square. An inch square is about this big, isn't it? 1 inch by 1 inch, that's an inch square. Square inches. Does that make sense? Because it was inches times inches, huh? Good. Let's go back. This should be easier, actually. They want the perimeter. So part B, it's off the screen here a little bit. I'll write it bigger. Perimeter. So we figured out the area. So for example, let's talk about this room. If I wanted to figure out the this one, if we want to get perimeter, what do we got to do? Just all sides, yeah, just the 15. There's where the 15 gets used, huh? 15, 19, 15, 37. We don't use the 12 at all, do we? Don't even, because that's not part of the outside. We use that for area, but we don't need it for perimeter. So it's going to be whatever, 15 plus 19 plus 15 plus 30. So basically top, bottom, right, and left, huh? All added up, 30, 49, 80, 86. Is that what it is? I think it's 86. Yeah. So 86 what?
Inches.
Is that square inches?
No. Linear.
Right. That's actual, just regular inches. Because those aren't squares. That's just length, linear, as Manuel says. That's just length. 86, like if I was going to go by, baseboard, it would just, how many inches, or how many feet, or whatever. Not square feet. I'm not buying squares. I'm just by length. Linear. So it's just regular inches on that. Everybody good with that? A little bit of geometry mixed in there? Questions? How do you convert between Fahrenheit and Celsius?
What? I don't remember.
You push the button.
Push the button? You got a button? yeah, that's right. That's right. We know how to do that. You hit the button. So let's see. What is it? It's negative 31 degrees Fahrenheit. 2 degrees Celsius. Well, there's a conversion formula. So you can write it on your there's no use in memorizing it. You can write it on your 3x5 card. I can't remember it. It's like
It's F equals 9 over 5 C plus 32.
Okay, I want the C one though. C equals 5 over 9. I think it's 5 over 9 F minus 32. I think. Is that right? I think it's that way. Let me double check. And see, I can just figure it out. If you did 212 minus 3, 180, 20, 100. Yep, that's it. Okay, so that's the right formula. You can just write that in. Yes, so there's two formulas. The other one was for F alone. And would you all say that was 9/5 C plus 32, like that? Yeah, so there's two formulas. You can write them both on your 3x5 card for the next exam. That's for converting one way or the other. There's the two conversion formulas. So how do you know which one you want to use? Well,
You need a C.
you need C, exactly. That's what Manuel's saying is right. You basically look at what you want. What are they asking you for? We got to find C, so you do the one that already has that alone. That'd be this one. Does that make sense? So we want the one that's already got C alone because C is what we're trying to find. Is that good? So I'm not going to use that second one. I just wrote this down so you'd have them both, for your notes and everything. Because they might ask you the other question when it's random, the homework. So it might give you give a C and ask for an F. So anyway, I'm going to use this one. So what am I going to do? I'm going to plug in F. Negative 31. We never see that in Fresno.
No.
Fresno, Central Valley area, do we? I thought the heat was over. It's kind of come back.
That's what I said.
2 more weeks. It'll be beautiful here. It'll be like San Diego here. It's beautiful in the fall and spring in the Central Valley.
I'll have to see that.
All right, so then this is minus 63. I just combined those. Am I going too fast? That makes sense so far? Everybody see what happened there? Right, if you lose $31 and lose $32, loss and a loss, a big old loss, just add those up. Okay, now, C's already alone, so I don't need to do anything but just work out the numbers and I'm there. You can choose your calculator if you want to. 5 divided by 9 times 63, or negative 63. Just hit the buttons. I'll do it by hand, but you could just do it with your calculator. C's already alone. You see what I mean? There's no special maneuvers to get C alone. It's already alone. It's just work out the numbers on your calculator. But I'll show it by hand if you want to see it. What do you do when a fraction is interacting with a whole number? What do you do when a whole number is interacting with a fraction? Put it over 1 to make it look like a fraction. Cross cancel 9 into 63. 7 times. You multiply what's left over. 5 times minus 7. Minus 35 degrees Celsius. Is this good? Questions I can answer? So I used this formula because C was already alone and they wanted C. So really you could have just worked it all out in your calculator. Okay, so there's number 9. We got a rectangle. The width is 2/3 the length. The perimeter is 220. So remember, this might be tricky. When you're doing a word problem, remember how you always start. You let the first thing be X. Yeah, just get rolling that way. So let the first one just be simple X. All right, let me give you a second. If I was to say, hey, I've got, let's just think of a really simple number that you're comfortable with. Like, how about 6? If you add, let me just break it. There's 6 things here. 1, 2, 3, 4, 5, 6. So if I got 6 things, what would 2/3 of that be? If you broke it into thirds, there's thirds, right? There's 3 even pieces. So what are 2/3? How much in 2/3?
1 to 4.
1 through 4. Right? Isn't this and this together 2/3 of the whole thing? So 2/3 is, it always is going to mean multiply. Whenever you say 2/3 of 6, it means 2/3 times 6. So of means time. Maybe that's the best way I could say it. Whenever you think of, or they say of, that always means times. So when they say the width is 2/3 of, I guess I didn't write in the word of, but it's kind of understood to be there. If I was using better English, it would be there. 2/3, so the width is 2/3 of the length. Whenever you see of in a word problem, it always means times. So the width is 2/3 of times the x. Is that making sense? Rather than 2/3 plus x. So it's 2/3 of, and of means times. So let me let you take it from there. You could draw a picture if it helps you. You don't have to at all. But if it helps you at all, rectangle, and we're saying the length, the width, That's kind of the idea. So how are you going to get, they're saying perimeter is equals 220. So how do you figure out? So how would I figure out the perimeter of this room? If I said, "Hey, I want to know the perimeter. I'm going to the store. I'm going to buy some new baseboards. So I'm calling up Karina. I need to know the perimeter of the room. I'm here at Home Depot. What would we do? Wouldn't we just measure this wall? Measure that, and measure that. We just add them all up, huh? So perimeter is just to add the 4 sides up. Those 4 sides added up, huh? That's what perimeter of any object is. Just add up all his sides.
But it already says it is 220.
Right. So the right side will be the 220. The left side will be the x stuff all added up. Does that make sense? So this left side is going to be x plus 2/3 x. Well, I'm probably running out of room. Let me do it a little neater. So the left side's going to be x plus 2/3 x plus 2/3 x is 220. Is that making sense? You could do those in any order. It doesn't matter. Just the 4 sides all added up. Perimeter, which is the 4 sides. The perimeter is these 4 sides, is equals 220. So these 4 is the perimeter, huh? Is that good so far? So perimeter is the 4 sides added up. Now, that's not an easy equation to solve. Got all them fractions and at x's everywhere. How are we going to do that?
We got putting together the x's. And,
Here's the wall.
2x, 2 times x, 2/3.
What do we do whenever fractions show up in our problem? Who do we call?
The shooter.
The shooter, yes. The hitman, right? You want to do that first. So whenever you've got fractions, whenever we got fractions in there, you want to call the hitman to take them out. Getting the hang of that? I'm trying to tell these goofy stories. I think trying to stick them in your mind. As I try to make my stories Well, that was real, though. I really met that guy. He came to my office. He was an interesting guy. But that's what I told you about that. So you're going to multiply through by 3, 3, 3, 3, 3. Because that's the denominator, huh? Is that making sense? Everything by 3. So I'm going to go 3, 3, 3, 3, 3. It's got to be equal treatment. We got to treat our hitmen equally. Right? Equal on both sides. Got to do the same thing to both sides to keep the balance. Is that making sense? Every time you see fractions, you want to do that. Every time you see fractions, call the hitman, multiply through by y. Whatever's under the bar, that's what you want to put top, 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 all the way across. And then cross-cancel whatever you can. Let him do his job. Let him take out those denominators. That is his job. Let him take those out. So right here and right here, he'll take those out, won't he? That's why we called him. Because we didn't like fractions. Wanted to get rid of those fractions. Is that good? So what does that leave us now? 3x. 3x. What's left over here?
Plus 2x.
Yeah, 2x.
Plus 2x.
Plus 2x. And what is, I think that's 660. Use a calculator.
Yeah.
Much nicer now, huh? No more fractions. See how the hitman always takes out the fractions? Technically he takes out the denominators, huh? Now getting more comfortable? We'll do fractions all 18 weeks here. So, want to get more and more comfortable with it. Be the same game plan every time.
10x.
So when y'all go to statistics, fractions won't be hard for you. Or whatever class you're going to. So 3x and 3x and 2x and what is that? 6, 7, 9, 10x? Just add them all up. Last step is always, exactly, division, huh? Divided by 10. X is 66. That's the key. Let's go unlock it. Aren't we done yet? Let's go unlock the doors. We got the key. We just got to stick it in the lock. Click, click, right? Unlock those 2 doors. Well, maybe it's a little harder than that. I'm making it seem easier than it is. So I'm going to put in the 66 right here. The length is just 66. No big deal there. But for the width, let me kind of get this out of the way. You can use your you can just do it in a calculator. The width here is going to be 2/3 x, and now I know x is, what is it, 66. So just take 2 divided by 3 times 66 on your calculator.
44.
You'll get 44. Yeah, you can just do that in your calculator. Just 2 divided by 3 times 66. Can you guys all see that green color back there? Is that okay? A little lighter, huh? 2 divided by 3 times 66? 44.
Or you can just cross-cancel.
You could, yeah, if you wanted to do it by hand, you could put this over 1 and cross-cancel. That's exactly right. I was saying just use your calculator. But yeah, you're totally right, Karina. You would just put that over 1. This goes in there, 22. 2 times 22. There it is. That would be the by-hand method to get the same answer. So the width is 44. The length is 66. How we doing? Like I'm just laying these problems on you. These are hard ones. You guys are paying me to do this to you. Can't believe it. Questions? Is that okay? Okay. So, okay, it's all these words. Let me just cut through it for you. It's 3.5 hours at, was it 54? 54 miles per hour. And the question is, what's the distance? So 3.5 hours at 54 miles per hour. What's the total distance? What are we going to do here?
We have to multiply 54 times 3.5. 3.5.
Yeah, Manuel's got a good sense of it. That's right. Is that feeling right to you? That is right. Right? Because if you're driving your car at 54 miles per hour, going down the highway, 54 miles per hour, what does that mean? That means every hour you cover 54 miles, huh? You're doing 54 miles per hour. So every hour, 54 miles, 54 miles, 54 miles, you just held it steady. Okay? So if you do that for 3.5 hours,
They give you 189 miles.
then what it is?
Oh.
We're just gonna multiply,
Okay.
aren't we? Does that feel right? That is right. Is that feeling right? You're just gonna multiply because every hour you do 54 miles times 3.5 hours, and you just do like Manuel was saying. Just make that 3.5. 3.5. Just use decimals. Be easier on your calculator. 3.5 times 54. Just hit the button. Would you say it was 189?
189.
189 or 99? 189. 189.
Miles.
I can't understand the numbers when you say them in Spanish like that. I'm just kidding you. 189 miles.
Cool.
Is that good?
Yeah.
189 miles. So that's just it. That's nice. No x needed. We just simply multiply. Hours times miles per hour. So we just the units told us that. That's how I survived physics, was just watching units like that. I used to really not like units before I took physics, and then I realized how helpful they were to me. So that tells you just to multiply those. The units are kind of telling you, right? Miles per hour, that many hours. Oh, multiply. All right, let's do. So I just kind of cut out all those words. There's that special science formula. N is the number of chirps per minute or something. Is that what they said it was? Did you guys notice the word? Yeah. So T is the temperature. N is the number of chirps per minute. So basically, if we know it's 50 degrees outside, how many chirps per minute are the crickets going to be chirping? So what are we going to do? Basically, we got to take this equation. They're telling me T is 50. So pop in the 50 for T, right? So grab that 50. Plug it in right there. Is that good to there? See what I did? Are we okay so far? So let me give you a second to solve that. Here's the wall, and N is saying, I want to be alone. Get rid of all this stuff. I want to be alone. Right? So it's making sense. So 4, 4, 4. Is that good? And this one, let him do his job. He takes it out. Is that getting easier? That's how we always get rid of fractions. We just multiply through by whatever's under the bar. So take it from there. Is that good? Is that making sense there? What's the next step? Minus 200. Or you combine. Yeah, did you guys combine? Either way. It's totally fine. Yeah, did you combine these two? That's fine too. You could do that or subtract 200, whatever. That'd be 160 plus N. That's totally fine to do. Just those two on the same side, just subtract, right? And then you can just subtract the 160, huh? Subtract 160. N is 40. 40 chirps per minute is what the crickets are going to do at that temperature. Is that okay? So the main part is always the fractions, isn't it? So what do we do when we have fractions? Anything under the bar, you just multiply by that number under the bar. Like that. Just multiply by that.
How did you get the 160?
What's that?
How did you get the 160?
Okay.
Oh, yeah. I just did 200 and the minus 40. I just
They go
subtracted
40
them.
times 100.
Oh.
Because they were on the same side. So I just did 200 minus 140 to get the 160. Is that good?
Doing the 0 on the other side and then.
You could do that. That's okay.